Welcome to Matematika channel again. In this time, we're going to discuss this integral problem. Integral from 0 to 1, ln x plus 1 over x squared plus 1 dx. Actually, I did this problem about a year ago, but I made a video in Bahasa Indonesia. So, I'm gonna redo this problem, but now in English. Okay, so first of all, when we see this kind of expression x squared plus 1, one of the suggestions is to use the trig substitution. So since we know that tangent squared plus 1 is equal to secant squared, we can try to use substitution x equals tangent t. So then we have dx equals secant squared t dt. Okay. Now we can change also the bound of the integration. Okay, so when x equal to 0, and then so when x equal to 0, then t is also equal to 0, and when x is 1, then t is pi over 4. Okay, and then we replace the dx by secant squared t dt. So we have here secant squared t dt, and then on the bottom we have tangent squared plus 1, and I mentioned it earlier that tangent squared plus 1 is exactly secant squared. And on the top we have ln tangent t plus 1, and we simplify a little bit to have integral from 0 to pi over 4 ln tan t plus 1. We can cancel this secant squared. Alright, so let's cancel out. So we're left with integral of ln tangent t plus 1. Okay, so now we need to deal with this lower bound and upper bound from 0 to pi over 4. And one of the useful technique, well actually not quite technique, probably it's kind of trick or some I don't know, is to make a substitution so that we can somehow reverse this bounds. So the bounds will change from pi over 4 to 0. And in order to do that, so we will do some substitution pi over 4 minus t. By using this substitution, whenever t is 0, we have u equals pi over 4, and when t is pi over 4, then when t is pi over 4 and the u is equal to 0, and we also have the u is equal to minus dt. So this substitution is in order to have pi over 4 up to 0, and then the dt can be replaced by minus du. And then here we have ln of tangent, so t is pi over 4 minus u plus 1. Alright, and then we have integral from 0 to pi over 4 ln tangent pi over 4 minus u plus 1 du. Okay, so we have integral. The first one is this one, integral of ln tangent t plus 1, and the second one is ln of this one. Okay, and then usually it's somehow that in many occasions that we can add up the integrals, or we can do some kind of operation to the original version and the later version, and somehow if we add them up or we multiply, or I don't know, if we subtract something like that, it turns out we get a simple looking integral. Okay, but at this moment this seems very different. Okay, so to make this expression more simple, let's use some tangent identity. So recall that tangent a minus b is equal to tangent a minus tangent b over 1 plus tangent a tangent b. So then this expression can be turned into integral from 0 to pi over 4 ln. Remember that tangent of pi over 4 is equal to 1, so we have 1 minus tangent u over 1 plus tangent of pi over 4 is 1, and now we rewrite this one as 1 plus tangent u plus 1 plus tangent u. That is exactly 1. And if we simplify this, what do we get? 1 minus tan, this is 1 plus tan, so we're left with 2 on the top and 1 plus tangent u at the bottom. Okay, now if we look at very carefully, this expression and that expression, I'm sorry, I should still have the ln on the here. Okay, so we have 2 ln. The first one is ln tangent t plus 1, and the second one is ln 2 over 1 plus tangent u. Okay, now both of them are equal to I. Okay, let's put it here. So we have this expression. Okay, and then let's call this I. So we have I plus I. So the first I is coming from this one, integral from 0 to pi over 4. Both of integral are from 0 to pi over 4. So ln tangent, okay, just to make it easier to comprehend, let's change this dummy variable into z, and as well here we will change the u variable into z as well. So z plus 1 plus ln 2 plus tan z plus 1 dz. And recall that we have the property that ln a plus ln v is equal to ln a times b. So therefore we can just multiply the input of both ln to get, what do we get? ln 2, right, dz. So therefore we have 2i is equal to ln 2 times pi over 4. Therefore the I that we are looking for is pi over 8 times ln 2. Alright, so that's all. Okay, thank you for watching. Don't forget to subscribe on Matematika channel. See you again on the next video. Bye bye.